Okay, we have a one-cylinder engine here behind us with a plexiglass and just one coil. Normally we have 3 coils, but we want to see the reaction, and that's the reason for the plexiglass. So we can see what is actually happening inside the cylinder every time it fires. We have a very small amount of inert gases, namely helium, neon, argon, krypton, and xenon, in here for several purposes. Some of the gases basically will transfer energy, other gases will cool the cylinder. So the engine does not need a cooling system at all. No fuel goes in, everything is sealed, and our cooling system, the engine cools itself.
What I have seen and the effects that are seen on the videotapes that I personally took have not been tampered with in any way. In fact, most of the effects are not visible to the naked eye and were not even known about until I started replaying the tapes back frame by frame and started noticing incredible anomalies that could not be accounted for by any other anything that I'd ever heard of or seen before. I've observed them remove all the air from the cylinder and register -2 atmospheres of pressure, and then saw them put in only 120 cc's, which and then ignited was able to push this piston down, which is not considered possible under the current laws of physics, which would allow for an inert gas to produce light but not pressure. There appears to be that in the vacuum, or the most vacuum with a slight amount of noble gases, they're charging, and it creates a frequency that acts as an antenna and draws in certain energies.
There it is. See, there's no reaction yet, no blast. And then the next frame or two there. See the green on the outside? White. Intense light. There's a white light.
Well, the theory is now that the vacuum here acts an antenna for positrons, and that the positron will be drawn in and connect up with one electron. And each blast is only the firing of one electron. Daggers of light would move towards the cylinder. As soon as it touched the cylinder, there would be a flash between frames, and then a plasma reaction would occur, which is, we're somewhat familiar with plasma reactions, and then the piston would be pushed down. And also another amazing thing is, it seems to be linear force rather than the usual three-dimensional force that we're familiar with, where it's just an explosive, a three-dimensional explosion. It appears to be force in one direction also.
There's that longitudinal serrated, very wide at the bottom, then to the right you can see how it's serrated, longitudinal energy that was released. And it works. So we have a 2-cylinder engine which we're now perfecting. All the components work. Okay, that's our top plate, aluminum top plate. This is just a sleeve. It's plastic. We just bought it from somewhere. And they come off, and they're just basically to hold the coils, 3 coils on each piston that we use to create a very powerful electromagnetic force field. Now, the uniqueness of this is that this engine is not radioactive. It doesn't pollute. There's no fission, no fusion, so there's no danger of running it in this community, in any community. We don't pollute. And then there's a top piston that comes in here, and it seals the gases, and this will move up and down. The torque that we have tested already on a dyno is 1,000 feet-pounds of torque. So you want to compare it to any car. A normal car is about 250 feet-pounds of torque. And there you can see our engine running steady at about 120 RPM. There's a coupler to the flywheel. We just want to do a test here. See how now we've got 519, 520. We're talking about no fuel. We run nothing, we burn nothing, and we use nothing. This is the head of the piston. And then here we'll go, we'll put Teflon rings, which will seal the piston itself so that none of the gases can escape. This is stationary. this one will move up and down. You see, there's another portion that goes here, and the top plate we took off. Okay, it'll bolt on top so that this will remain stationary. Okay, every cylinder will be like this, but steel, not the engine. And the amount of gas that goes in there, a very small amount that we put in here, we measure by cc's, would cost, after process and all, about 50 cents per cylinder. So it costs $1 to run that engine for an extended period of time. Screw on, and this is how you can screw these off and refuel your engine when it runs out of fuel, if it ever runs out of fuel. These inert gases, we have calculated that they will run, maybe 10,000 hours. There's no limit. We don't know if it'll run 20 years. We haven't run it 20 years, so we don't know. We're going to give you just a demonstration to show that the bottom portion runs and works. We have the battery and, of course, the starter, and Jake's got the button. And it's going to be real noisy because it's a real big starter. If a regular automobile engine in mass production costs you, what, well, $5,000 per engine, roughly? But it has so many components to it that we don't, and therefore this engine should be much cheaper than a standard combustion engine.
Here we are removing the batteries, which are two 12-volt batteries from our engine. Basically, we're trying to show that we do not need the batteries once the engine is running. The engine will produce its own energy and can run without any input from any outside source whatsoever. And this is one of the reasons we're doing this. Move the batteries out. Down there you can see a little pedal. We can use that as a, like a pedal in your car. And you can adjust the timing sequence and the RPMs. Or we also have a hand rheostat where we can adjust the timing sequence of the engine, either fast or real slow. And here Joe is going to increase and he can decrease the RPMs with a hand rheostat. The engine here right now is doing about 700 RPMs. It's a two-cylinder engine, 400 horsepower, and we can produce approximately 350 kilowatt per hour by attaching a gearbox and a generator to it. This is a small engine. We can do 4, 6, 8-cylinder engines up to a megawatt if we want. We have it on a frame, bolted to a frame. There's a dyno. We're going to do a test with a dynamometer to show the power of the engine. Put a load on it without the batteries connected. Just the engine producing its own energy, its own power. And this runs just like a regular car engine, just has a key, push button. You can turn it on, turn it off. We'll show you that we can turn the engine off and then we start it up again, just like you would your regular car. There's a generator up there, and we have a belt. And on the side you see those long things are resistors. Because we produce so much energy, we have to dissipate about 300 amperes. And here we're going to drop the RPMs real low. The engine will not shake, throw a rod, very solid, very smooth running at any RPMs. So it's doing about 75 there. And then he'll increase it again.
We're watching something that I feel has never been observed before. I mean, the particle accelerators that Jimmy was talking about, they're surrounded with huge mega-Gauss magnets, you know, and they're completely enclosed, and there's no way to observe the reaction except by, you know, the effects that it creates in like a a cloud chamber or something like that, where we see the effect of the thing but not the thing directly. So this may be one of the few opportunities we have to see under controlled circumstances where we can actually watch an effect like this.
We can build anything. If we have the money, let's do a 4, let's do a 6. 6-cylinder will give us about 1,200 horsepower.